Hi, in this video we solve question number 13 of IIT JAM 2021 mathematics paper. This is a question from vector calculus where S is a surface in R3 and we are given with a vector field F arrow and n hat is a continuous unit normal field to the surface and we need to calculate the surface integral of the vector field. Now there is a physical meaning of this surface integral of the vector field. If the vector field represents the flow of a fluid over the surface, then this integral is the amount of fluid that flows through the surface in unit time. There's a detailed mathematics behind how this integral is calculated. We are not going to discuss that because it is beyond the scope of this video. Instead, we will see a standard procedure to solve such integrals. Here is the technique to solve the surface integral of the vector field. Now suppose the surface is given by equation z equals gxy, then the surface integral of the vector field has the following formula. You compute the integration of the inner product of the vector field with the vector given by minus the partial derivative of g with respect to x, I component, and then partial derivative of g with respect to ij component plus k component with respect to the area of the region D, where the region D is the projection of the surface on the xy plane. Very good. Now let us talk about the given problem. The equation of the surface is given as z equals x times y. Now this is our gxy function. The region D is the unit disk in the xy plane given by x squared plus y squared less than or equal to 1. So our surface integral of the vector field is given by the integration of the inner product of the vector field f. What is vector field f? It is given by yx hat plus xj hat plus k hat. Let us write that yi hat plus xj hat plus k hat times minus gx. The partial derivative of xy with respect to x is y. Similarly, you have minus the partial derivative of g with respect to y is x, and then the third component, integration with respect to area over disk. Now let us simplify this integral. Carry out the dot product, you get minus y square minus x square plus 1 integration over d. Now this can be written as integration over d 1 minus x squared plus y squared bracket close with respect to the area. Now here is a pictorial representation of the disk of radius 1. Whenever you have such integral, it's easier to solve it with polar coordinates, in which you have dA given by r dr d theta. The radius is connected with x squared plus y squared like this. The radius varies between 0 and 1, and the angle theta varies between 0 to 2 pi. With that substitution, the integral gets pretty easy to solve. So the integration 1 minus r square r dr d theta, r varies between 0 to 1 and theta between 0 to 2 pi. Now since there is no term dependent on theta, so we just separate that integral out. We have this integral times integration 0 to 1 of the remaining term, which is 1 minus r square r dr. The integration of the first term is simply 2 pi, and the other integral is r minus r cube with respect to r, and then we use the simple integration formula to solve this. This is given by r squared by 2 minus r power 4 by 4. Apply the limit of the integration. We have 2 pi times 1 by 2 minus 1 by 4 minus 0. Simplify, you get 2 pi times half minus 1 by 4 is 1 by 4. And this gives the answer pi by 2. So the correct option is B.